This is America in Space, a weekly news and information program on current events dealing with the space industry.
Welcome, and thanks for joining me today. I'm Dawn Meyer, Space Coast News Editor. Going to the moon will help NASA collect crucial data and develop the necessary tools and strategies to one day safely send human explorers to Mars. The journey to Mars will take much longer than a trip to the moon, and crew members will face much more radiation exposure, thus making space radiation one of the biggest challenges for a human journey to Mars. Unlike Earth, Mars has no magnetic field to divert radiation, so NASA is developing technologies and countermeasures to ensure a safe and successful journey to the Red Planet for the astronauts and a safe return. Pat Troutman, Human Exploration Strategic Analysis Lead at NASA's Langley Research Center, says that space radiation won't stop NASA's human exploration.
So a lot of people think that radiation will keep NASA from sending people to Mars, and that's not what the current situation is. We have techniques, we've discussed ways of getting there faster. We know that we add these various mitigations up, that we can have a successful Mars mission, a healthy crew, and have them live a very long and productive life after their return to Earth.
Lisa Simonson, space radiation element scientist at Langley, and Pat Troutman describe what they see as the radiation challenge and what is being developed by NASA to predict and mitigate the health effects of space radiation on astronauts.
I think one of the most challenging parts for the journey to Mars in terms of the humans and not necessarily the technology to get there is the risk of radiation exposure and the in-flight consequences of the exposure to radiation as well as the long-term health consequences of exposure.
There's two parts of radiation we have to protect the crew from. One is a solar particle event, where there's a solar storm and these energetic particles stream out. Fortunately, we know how to protect the crew from that. We put them into a shelter that's shielded by lots of water. And actually, they're very short duration, hours to days at most. They can come out and continue with their journey. That's the one aspect of radiation we know how to protect against. The other, which we really don't have a firm handle on, is galactic, cosmic rays. These are highly energetic particles that come from all over the galaxy towards the solar system and Earth. You can't shield against these. They're so energetic, they rip right through all metals, all plastic, all water, and all cellular material. And as they rip through these materials, little electrons and protons pull off of them, and you end up getting a cascade effect of radiation throughout the materials. And sometimes going through certain materials causes a worse radiation environment for the crew that had it gone through other materials. So we try to design the spacecraft out of materials that shield the crew from these, but also do not produce more hazardous particles as a function of being impacted with it.
So the moon is sort of a stepping stone now for going to Mars. Sustained lunar exploration will help to determine whether we have the technology needed to protect astronauts on long-term space travel to Mars. From Florida's Space Coast, this is Dawn Meyer for About Space Today.
Thanks for listening. Be sure to share our program with your family and friends and follow us on Facebook. Join us each week for news and information on America in Space.